Hi everyone, welcome to lesson 3. Today we are going to be looking at properties of organic compounds. The first one we'll be looking at is low melting and boiling point. Most organic compounds are volatile and most of them have low melting and boiling point. And this is due to their weak intermolecular forces of attraction, which makes it easier for them to break apart into gas phase. There are several factors that contribute to low melting and boiling points. First one is the weak intermolecular forces. Substances with low melting and boiling points often have weak intermolecular forces. The second one is molecular size and shape. Generally, smaller molecules tend to have lower melting and boiling points compared to larger molecules. The third one is molecular polarity. Molar molecules, which have an uneven distribution of charge, tend to have higher melting and boiling points compared to non-polar molecules. This is because the polar molecules have stronger dipole-dipole interactions or hydrogen bonding, which require more energy to break. Fourth one is molecular weight. Lighter molecules with lower molecular weight generally have low melting and boiling point compared to heavier molecules. This is because lighter molecules have weaker intermolecular forces and lower molecular masses, requiring less energy for phase transition. The next one we're going to look at is solubility. Solubility refers to the ability of a substance, known as the solute, to dissolve into another substance, known as the solvent, to form a homogeneous mixture called dissolution. So in solubility, there are three things to note. The first one is solute, next one is solvent, and the third one is solution. The solubility of a solute depends on various factors, including the first one, nature of the solutes and solvents. The second one is the temperature. The third one is the pressure. And the last one is the particle size. The third one is covalent bonding. Covalent bonding is a type of chemical bonding that occurs when atoms share electrons to achieve a stable electron configuration, as you can see in carbon. So the key features of covalent bonding include the electron sharing, electronegativity, bond length and strength, multiple bonds. The fourth one is chemical reactivity. Chemical reactivity refers to the ability of a substance or a chemical species to undergo chemical reactions with other substances. Several factors influence the chemical reactivity of a substance, including the electron configuration, electronegativity, bond strength, presence of functional groups, temperature, and pressure. The next one we're going to look at is the biological activity of carbon. The biological activity of carbon compound stems from the unique properties of carbon and its ability to form stable covalent bonds with other atoms, including itself. Some key aspects of biological activity of carbon compounds include biomolecules. Now, in biomolecules, carbon compounds such as carbohydrates, lipids, proteins, and nucleic acid are essential biomolecules found in living organisms. The next one is structural diversity. Carbon's ability to form stable bonds with different atoms and its capacity to create long chains and complex structures results in a wide array of organic compounds with diverse properties. The third one is reactions and metabolism. Organic compounds participate in numerous biochemical reactions and metabolic pathways within the cell. The next one is drug discovery. Medicinal chemists use organic chemistry principles to design and synthesize organic compounds with desired biological activities, such as pharmaceutical drugs. And the last one is environmental impact. Organic compounds also play a significant role in environmental processes. Let's look at isomerism. Isomerism is a phenomenon in organic chemistry where two or more compounds have the same molecular formula but different structural arrangements. Now, this simply means that they have different physical and chemical properties despite having the same number of atoms or each element and the same overall mass. There are several types of isomerism in organic compounds, including structural isomerism. This structural isomerism arises from differences in the arrangement of atoms in the molecule. It can be further categorized into the following subtypes: chain isomerism, functional group isomerism, position isomerism, and tautomeric isomerism. Number 2 is stereoisomerism. This type of isomerism arises due to the different spatial arrangements of atoms in a molecule. There are two main types of stereoisomerism. The first one is geometric isomerism. Now, this occurs when two or more compounds have the same molecular formula and bonding arrangements but differ in spatial arrangement or orientation of groups around a double bond or a ring structure. Example is cis and trans isomer of dichloroethane. The number 2 is optical isomerism. This occurs when two or more compounds have the same molecular formula and bonding arrangements but differ in their ability to rotate plane polarized light. The number 3 is conformational isomerism. This type of isomerism arises from the orientation of single bonds, leading to different conformations or spatial arrangements of atoms in a molecule. Example is the chair and both conformations of cyclohexane. The fourth one is ring chain isomerism. Here, the isomers differ in the arrangement of a cyclic or acyclic structure. Our next class will be bonding and molecular structure.